Hello, everyone. Thank you for joining us today for this webinar about the BeeGFS parallel file system. My name is Wade. I'm a member of the marketing team here at Advanced Clustering Technologies. And I want to encourage all of you as you're listening to these presentations to share any questions you may have in the chat functionality of Zoom. And our presenters will be answering questions at the end of the webinar today. I would like to start by introducing two people who are joining us from ThinkParQ, Marco Merkel, who is the Vice President of Worldwide Sales at ThinkParQ, and Volker Pence, who is a consultant for ThinkParQ. And we will go ahead and get started. Thank you, Marco.
So the topic of today is accelerating extreme HPC scale-out environments with BeeGFS. And you see here also a little shield which shows us that BeeGFS being nominated third time in a row for the new product or technology to watch. That's actually driven through partners and customers. And yeah, we have today 425 installations out there in the fields, and especially now North America is starting up. The agenda today, before I'm jumping on the agenda today, let me introduce Volker Pence. He is a system architect. So together with Volker, we are helping to design architectures or appliances. We are running trainings and high availability consultancy services, so enabling partners and customers on BeeGFS. My name is Marco. I'm based in Munich, and as said, I'm running all sales operations for BeeGFS and partnerships. The agenda of today is an overview about BeeGFS, really quick facts on BeeGFS, the enterprise features, and how BeeGFS works. That's wow, that's swapping over automatically. Right, and just flipping back. How BeeGFS works, that will be covered by Volker, and some interesting use cases and a conclusion. All right, so let's jump into the part where BeeGFS is actually the leading parallel cluster file system, and it's mainly designed for performance. So no, the mouse is not doing for this. So mainly for performance, and it is well balanced for small and large I/O pattern. It is also designed for scalability, so it helps you to increase the file system performance and the capacity seamlessly and non-disruptively, and linear. So as you're adding, you can add more hardware components on metadata level or on the storage node level. It is easy to deploy. So it's easy to integrate in existing infrastructures without changing any workflows. And it is very robust by introducing high availability designs, which actually enables continuous IT operation. Now, some quick facts on BeeGFS. What is the differentiator on BeeGFS? And it's really state of the art, because from the server side, BeeGFS runs in the servers, in the user space. And we really can say it's a hardware independent parallel storage solution, and it is available source. It is public available, so you can download it at any time from beegfs.io. It runs on, since it's running in the user space, we are supporting x86, ARM, AMD, and Open Power. And we are supporting various distributions like Red Hat, Slash, Ubuntu. BeeGFS supports Rocky, TCP/IP, and InfiniBand, so we are fully agnostic to the interconnects, so we can support here multiple interconnects. Plus, it is enabled for NFS, CIFS, and Hadoop. So we are doing re-exports for NFS and CIFS. From the perspective of the administration, that's super simple, because we are running on top of arbitrated file systems like ext4, XFS, and ZFS or ButterFS. That makes the administration very, very simple. So you can upgrade the infrastructure. You don't need to compile the kernels or something like that. And actually, it presents a scalable, multiple threaded architecture to the system, to your infrastructure. Let's talk about enterprise features and community version. So in this table, you see, because everybody can download that without registering. It's available source, and this source can be reviewed. And customers are allowed to use the community version. That's simply mainly for the scratch jobs, and that can be used for cost-free. That's you get also here free updates, and you have access to use binary packages and the source code. As soon you do need more functionalities, like resiliency options, quota enforcements, ACLs, and storage pool management, this does require an enterprise functionality. So these functionalities are disabled into the product, so you can test these functionalities for 60 days. And yeah, you can contact then our partner like Advanced Clustering for a support contract. So it's a support subscription. The pricing is actually very, very fair because it's based on the number of storage nodes. So it's a fee to the storage node, usually combined on the warranty, so 3 years or 5 years. And it is fully hardware capacity independent. That makes it also very simple and easy to invest in such environments. The support is usually next business day, and L1 and L2 services are covered by advanced clustering. I added here also a link to the EULA, which describing actually this summary and which kind of versions and how long you can use it. All right. Let's jump to the part how BeeGFS works. And I'm passing the ball over to Volker.
Thank you, Marco. And I'm going to do a quick screen share and start my presentation. So how BeeGFS works. The BeeGFS architecture consists of several services. So we're having the client service, the management service, metadata services, storage services, and monitoring services. The first 4 are mandatory, and the last one is an optional service. So, and now let's go into a little detail how the services work and what they are what they have to do. So, starting with the management server. So, the management server is a meeting point for all servers and clients in the BeeGFS cluster. He has an overview and registers services, checks their state. So, the management server checks if all of the services are available, but he's not critical for performance and he stores no user data. So basically he needs very little disk space. And typically the management server is not running on a dedicated machine. Of course, you can set it up with running on a dedicated server if you want to, but usually the management server runs on the same servers like metadata or storage if you like to. The metadata service, he stores the information about the data you are storing at the storage services. So directory information, file and directory ownership, location of the user data files or of the chunk files that are stored on the storage services. But he is not involved in data access between open and closing of a file. He just records where the chunks are written to and so on. But of course, he has some more requirements in regards to the management server. So he needs a faster or more CPU cores. So the more CPU cores you are having, the better you are, because it's a multi-threaded model for the metadata services. And so you get a better performance if you're having multi-core CPUs or if you have more sockets with multi-core CPUs. And each of the metadata servers, you can have more than one metadata service in the BeeGFS cluster, manages one target. With the target, we mean a disk or a partition that is solely for the metadata server. And each of the metadatas can only have one target. And this is typically because it's a partition or a storage device RAID 1 or RAID 10 with SSDs or NVMEs because you need high throughput. BeeGFS is a high performance file system. And the storage services, they store the data. So they are responsible for all of the data you want to store in your cluster. And each of the storage services is just storing a chunk of the data, which means just a little part of your data, and it's all distributed on all storage servers available in the BeeGFS cluster. And this makes up for the performance of BeeGFS. And you can have, contrary to the metadata servers, more than one target for a storage server. So you can scale up your storage servers. So you're having the possibility to have a scale up and a scale out environment with BeeGFS. And usually you are having dedicated disks or partitions for the storage targets, which run in a RAID 6 or ZFS RAID 2 environment. And it can be internal volumes or externally attached volumes via SAS or fiber channel. And storage targets can have a mixture of disks like HDDs, NVMEs, or SSD devices. The communication between metadata and storage targets are usually with RDMA interfaces, be it InfiniBand, OmniPath, or Rocky, and you can have multiple RDMA interfaces to have your data transferred in parallel. And you can have different subnets as well. And usually you want to have some statistics for your BeeGFS cluster. And for that, we are having a monitoring user interface, which is based on Grafana and InfluxDB. So you need InfluxDB and Grafana to be able to use the interface. And we have predefined dashboards for the Grafana interface. So you are able to see disk throughput, disk usage, network traffic, work requests for your storage targets, for the metadata targets, and client throughput, and so on. And that was a small and very fast overview over the BeeGFS components. And with that, I would like to give over back to Wade.
Thank you, Volker, for that.
Yeah.
And I would like to turn it over now to Kyle Shoemaker, who is the president and CTO of Advanced Clustering Technologies.
Thanks for attending, and thanks for that presentation, Marco and Volker. Let me go ahead and start mine here. All right, so we're going to talk a little bit about our company and the services we provide around BeeGFS and our solutions. So a little bit about us. Advanced Clustering has been around for 20 plus years. We've been doing lots of business with universities, government, national lab, all across North America. And we're take a very consultative approach with dealing with customers and work with them from grant writing to RFP publishing all the way through configuring deployment. A little bit about our typical customers. So our sweet spot, we feel, is really in the 1 million and under range. So this is more a departmental scale, not a supercomputer center. We find that this customer is fairly underserved in the market and has some limited HPC deployment experience. A lot of the times doesn't have a staff or full-time HPC staff or administrator to run their system. And they need high performance solutions, but they also need them to be easy to use and good vendor support. So I'm going to move into a little bit of our storage journey and how we ended up with using BeeGFS. So again, we've been doing this for 20 years, so we've seen quite a few different file systems come and go and tried a lot. So a little background here. So when we're first starting out and deploying small scale systems, we did everything with a kind of a single NFS server. So you know, NFS is being ubiquitous and easy to use and easy to manage, low cost of entry, and does perform well enough for small scale systems. But once CPUs kept getting faster and faster and hard drives did not get faster and faster, we started to see some real bottlenecks here. So NFS is pretty difficult to grow since it's confined to one server, no scaling, limited feature set, and we really started to see storage being a huge bottleneck for a lot of our customers. So we started looking into what our options were. And we've deployed lots of different parallel file systems to customers, be that Spectrum Scale or GPFS, Lustre, Panasys, Ceph, Gluster. I'm sure there's more that I didn't even include here, but these are the ones that I could come up with off the top of my head. And we ran into a lot of issues with various ones. I'm not saying this list applies to all of them, but there are certainly some issues along the way here, including stuff like proprietary hardware or very expensive licensing or extreme complexity, poor performance, or poor vendor support. So we started looking into in 2018 to find a better option. So we wanted to have a solution that would be kind of our default to offer to customers when the NFS wouldn't scale anymore. So we kind of came up with a list of features we wanted. So that would be a file system that was scalable and provide good performance. We needed native support for InfiniBand, since most systems were shipped with that. We wanted reliability features and software. A lot of these other file systems require lots of expensive hardware with HA built into the hardware. We were looking for something that could do that in software. We wanted ease of installation and use, a reasonable price tag, and some professional support. And we really found most of those solved with BeeGFS. So we can add, as Volker mentioned, multiple servers can be added to increase the performance and get with a global namespace. RDMA support is included, so it's not just InfiniBand, but OmniPath and Rocky as well. Reliability features, so there's buddy mirroring for both metadata and storage. Ease of installation and use, and this is a really big one for us, is that it's a simple RPM install. The server runs user space and a very simple kernel module to compile for the client. Reasonable price tag, again, it's as Marco mentioned, it's software only, no proprietary hardware, and it is a really low, reasonable cost on a per storage target basis. And then when things go wrong, we do have ThinkParQ, the makers of BeeGFS, here to support us. So in 2018, we became a BeeGFS partner, and we also got a Rising Bee Award for the fastest growing partner there in 2018. And then in 2021, we were promoted to the platinum partner level, only one of 3 in the Americas region. So now I'm going to talk a little bit about how we deliver BeeGFS. So what we really wanted to do was come up with a turnkey building block appliance approach. So we have 2 major components to that, is the hard drive based one and the SSD based one. So our reason for doing these kinds of turnkey solutions is because it's a lot easier to install. We have consistency. We know the performance characteristics. Because we have these building blocks, it's very easy to add performance and capacity. We definitely can mix and match the hard drive and SSDs as well in the different storage pools for the different use cases. So if we go into a little bit about our hard drive based storage block, it's actually 2 separate components. We have a 2U storage controller and a 4U 60 bay drive enclosure. We picked the 60 bay enclosure explicitly because of its size. We have a lot of customers that are installing into existing racks or into existing data centers. And while there are certainly storage enclosures that can get you 100 and some drives in a 4U space, many times they require custom racks, or they're so deep and unwieldy that they're not very usable. So this is a standard depth kind of array, so it's very easy to integrate into any existing infrastructure. So a little bit about that storage server itself. It's a 2U Ice Lake system. We use 2 Broadcom hardware RAID controllers with a super cap for backing the cache. We provide expansion slots for whatever interconnect you like, whether it's InfiniBand, OmniPath, or high-speed Ethernet. It also has 8 NVMe drives for converged metadata for small-scale deployment. So the storage controller here, as you can see in the front, has 8 drive bays. So on smaller scale systems, and where performance isn't the utmost concern, we can throw some NVMe drives in there and have built-in metadata into the same storage block. So the storage array is again a 4U 60 drive JBOD with 10, 12, 16, or 18 terabyte drives, redundant JBOD controllers. We can also support self-encrypting drives. So that's also handled by the RAID controllers we use. So if you're in a high security environment, we can definitely do encryption at rest. And again, it's a standard depth, no special rack requirements. So when we look at how we actually configure these, so we do this by pre-installing the OS with BeeGFS, and we subdivide that JBOD up into two components. We zone the actual JBOD into two 30 drive chunks, and we put 30 drives per RAID card. We found that really started to see a bottleneck in performance if we had more than 30 drives on a RAID card. So we found this was kind of the best balance of cost performance here. And we end up doing 10 drives per RAID set. So the RAID 6, so 8 usable drives and 2 parity for each RAID set. Do that to decrease the failure domain, and again, performance was the best in this kind of configuration. So that gives us a total of about 6 volumes per storage block, and we get about 6 gigabytes a second per each one of these storage blocks. And you can see the different sizes here, depending on the size of drive you pick. So so we can go from about half a petabyte to nearly a petabyte in one storage block. And again, as needs and space grows, you can add more of these. Very easy to add and grow them by adding more storage blocks, as well as it adds more performance at the same time. So our SSD-based storage block is again an Ice Lake Xeon system. This time we're using 3 hardware RAID controllers, and again expansion slots for any kind of interconnect you like: InfiniBand, OmniPath, high-speed Ethernet. With 24 data center grade SSDs. So in this configuration, we again do multiple RAID volumes. This significantly less drives because the performance of the drives are so much higher. And again, the bottleneck starts to be the RAID controller. So we get 3 volumes per storage block, about 10 gigabytes a second, which matches up nicely with 100 gig Ethernet or HDR100 InfiniBand as far as performance goes. And you can see the various sizes here, again, from about 70 terabyte to a little over 250 terabyte of usable space per SSD storage block. We really see these used a lot in fast scratch applications. And people mixing and matching as well. So all of the systems that we ship include 3 to 5 years of complete support. So that's both hardware and BeeGFS enterprise licenses, like Marco mentioned. So you'll have a single point of contact with us for any issue, whether it's hardware or software. This includes escalation to ThinkParQ team if necessary. We also try to include a 2-day ThinkParQ led remote training with each purchase, so it really gets you familiar with the file system and how it works, and get you up and running quickly and easily. So going to go over a little bit about some sample deployments here. So one of them here is Washington University in St. Louis. So this had 3 hard drive storage blocks with 10 terabyte drives, a total of 1.4 petabytes of usable disk space, and gets about 18 gigabyte a second in throughput. So you can see that provide them 3 times the performance of their previous system, and they're offering a lot more storage than they were ever able to before. And we got a quote here from the main sysadmin about already looking to double their deployment. A couple of different NASA deployments. One of them that was pure SSD based, so it's 5 separate storage blocks with 7.68 terabyte drives. So they have about a little over half a petabyte of usable disk space and over 50 gigabytes a second of throughput. This customer really started to see, as the CPU performance kept increasing, that their code would stop scaling because of the poor performance they were getting in other file systems. So this pure SSD based approach has really worked well for them and really allowed them to run larger jobs across more nodes all simultaneous. So it's really helped them in their throughput. This is a different NASA center that has a mixed solution. So where it's 4 storage blocks of hard drives and 1 SSD based one. It's over 2 petabytes of usable space, and they're getting about 34 gigabytes through a gigabyte a second throughput if you combine the 2. And another one, AbbVie, a pharmaceutical company. So also with hard drive based one, over a petabyte, getting about 18 gigabytes a second throughput. So I think that's about all I had. I'll turn it back over to Wade.
And now we would like to open it up to questions. And I see that we do have a few questions that have come through the chat.
A couple one. Maybe we start from down below. There's a question which is, what is the best way to integrate BeeGFS metadata with local Linux file system tools? For example, so commands like ls, la, or df or -h would reference BeeGFS metadata and not start indexing on their own, which takes really long time. Volker, that's for you.
Well, yes, we know that there can be a really long time if you do an ls or df on a BeeGFS file system if it's quite large. So we address this problem with a tool we call Beehive, and which is available in BeeGFS version 7.2.4 and will be further integrated in version 7.2.5. And this Beehive tool that does some integrating or indexing on the file system of BeeGFS, and therefore will be a much better, provide a much better response time for an ls or an df-h command on a BeeGFS file system. So we know that if you're using a normal ls-l, it can be take a horrible long time till you see an result. So that's why we develop Beehive.
Perfect. Thank you, Volker. Another question came in from John. Is all the capacity in BeeGFS file system in a single namespace? I can take that, Volker. Yes, it is. It presents a global mount point to all storage pools. So you can define pools where you're running them with quotas, NVMe pools or fast pools, flash pools, and can migrate fully transparently across one single mount point to different tiers. That process can be automated by implementing an epilogue prologue script into the workload management system like Slurm or Moab or whatever is in place. And the process can be automated. So John, good question. Thank you for that one. I've seen also here in the Q&A side, Lucas was dropping here something. With a special use case that goes to Kylie. Do you see Lucas' question?
I sure do. About the 20 nodes having 15 terabyte NVMe.
Yes, sir.
Yeah. Build a single shared system of node local storage providing of nodes can be turned off, rebooted without disrupting file system availability, without having capacity using mirror. So, I mean, with the using the individual drive in each node, you can certainly use the be on demand feature. But as far as that being able to turn off a node without disrupting its availability, I don't believe that would be the case. Is that we can verify that, Volker, right?
Yes, I can verify that. If you're using the Beyond feature, then turning off and on a single node won't be working, just because Beyond is BeeGFS on demand, which is a rapid deployment environment. So you have some restrictions in using BeeGFS in Beyond in the setup and in the usage. So if you're setting up just a usual BeeGFS cluster with your 20 nodes and each one has a 15 terabyte NVMe target, then it's dependent how you are going to set up BeeGFS in total. If you say, I'm going to use the default values for distributing the chunks on 4 storage targets in each return, then probably if you're turning one of the storage servers off, might certainly will have some sort of impact, but your cluster will be workable. And you will only not be able to access the data that is stored on the storage server you turned off. But usually it should work. And so, but basically the best performance is for BeeGFS is if all storage targets are online.
And the way we've deployed the beyond demand in the past has been as well through the scheduler. So we found that, you know, as the scheduler during a prologue, we would set up the file system and tear it down on the epilogue. So if a node were to go down or something in the middle, the file system would get destroyed at that point anyway. So, and the job wouldn't finish anyway. So I think that's really the best, we found the best use case of something like that is a temporary scratch file system while a job is running. So that's where it really makes the most sense.
Agree. Yeah, especially with Beyond, side note to this, We have very large deployments in AI environments where customers have very nasty IO pattern, and they want actually to decouple this pattern from the primary storage. And sometimes they have above a petabyte NVMe cards on top of it, and they're going for singularity or containerized infrastructures where the BeeGFS instances just waiting for such a moment to be enabled on top of this NVMe cards and relieving the bandwidth. So that can be really up to terabytes a second if necessary. It depends on the budgets and available NVMe components. So it's very powerful burst buffer layer, right? So we can really use what is in place. So we could use the NVMe cards on available client nodes, or we're running it on GPUs, for instance. So DGX2s or A100s can be used for such demand. So it's a good combination, which allows you to handle actually all IO pattern on one single global mount point. And that's the state of the art part, because it's not in the kernel. It allows you way more efficient to use small IOs and large IOs at the same time, and gives you the full bandwidth of your hardware gear.
So there is still one question from Andre. Is there a feature on the roadmap that promote and demote data between storage pool? So at the moment, there's not such tool on the roadmap for BeeGFS. We rely on third-party tools for promoting and demoting data in storage pools or in storage targets as such, like iRODS or other tools that are available. Beehive, as far as I know, has docking into iRODS. So iRODS can directly read data from the Beehive of BeeGFS, so, and therefore is capable of doing promoting, demoting faster within the BeeGFS file system. So unfortunately, so there's no tool directly on the roadmap for BeeGFS.
Right, correct. So iRODS is pretty modern on the market. I really like it because it's very lightweighted. It is not like TSM or DSF very deep into the metadata management. It's really, but it can recognize actually the events of the written files, and ingest and outgest data from different tiers. So we have multiple installations. The biggest installation I know is in Nagoya or University Pisa here in Europe, where they're using iRODS, and it's a fantastic combination with a very agile and elastic infrastructure. Right.
I see there's a couple more questions I got answered. One was, what is the typical cost of these systems like NASA with SSDs? It can obviously vary a lot, but Becky, we can take that offline and certainly give you a lot more information on pricing and what something like this would look like. And then it looks like there's one more on that, just on whether or not snapshotting. Do we have a solution for snapshotting or planned? Yeah.
Nope.
That's a short answer. I think it should be more elaborate. So yes, the problem is with snapshotting on BeeGFS is because it's a distributed file system. For being able to do a snapshot on a BeeGFS file system, you should be stop all BeeGFS services, so metadata, storage, and client access for the time of the snapshot. So we must make sure, and if you're having, let's say, 800 clients accessing the BeeGFS file system, which is not a very large number for clients, it's practically impossible to make sure that all of those stop at the same time and then do the snapshot and then start all of them again, and just without any disruption of the file system. So we have had some thoughts about doing snapshotting with the help of the underlying file system, for instance, using the snapshotting functionality from ZFS as a file system. but we ran into the same troubles with, hey, we have to stop it on all of the nodes at the same time to be able to do a snapshot with CFS on the storage targets or metadata targets. And therefore, at the moment, we are not having any possibilities, and we really see no possibilities to create a snapshotting functionality for BeeGFS. So it's not available at the moment.
Yeah, but I mean, still we have the CFS option. So if you're handling really critical data, and we still have the opportunity to introduce ZFS in combination with BeeGFS to handle then this snapshotting part, encryption, decryption, or deduplication. So that's actually possible to add this as an additional underlying file system, but actually it's not connected to BeeGFS. So we are not supporting the snapshots yet. It is an enhancement request, and we are thinking about that. So that's definitely a fact. And I have seen already some prototype snapshotting stuff. And as Marcus said, it is pretty complicated to set it up right in a proper way that you have a consistent snapshot of your data. Right. More things were coming in. Does ThinkParQ or
I think we've got that one.
We get that one. Yeah. Okay.
Yep.
Right.
There looks like there was another comment about underlying LVM snapshots, and I would assume the same thing applies with CFS, right? Is you can use the underlying LVM snapshots, but it's not integrated.
Right.
And then one in the Q&A here, features current or plan aimed at efficient backups or file system to file system replication from John. So I would assume the efficient backups would be assuming snapshot kind of approach as well, which I think we went over. I guess with the new Beehive feature, some of that could be better than in previous, correct? So could be implemented that way. So
yes,
yeah,
right.
But file system to file system replication, I mean, there's the buddy mirroring built into the file system, but no other kind of external replication engine in place.
That's correct. Yes.
All right, well,
all right.
I think we'll give it last call for questions. We got a question here from Charles. Do you have any numbers of speed of RDMA versus Ethernet? I have some numbers, but I don't have them available, and I can certainly get them to you on the testing that we've done, but I don't know if you guys have any, Marco or Volker have any comment there as well.
Well, depends on the setup as usual.
Yeah.
So
right.
if you're having say an HDR RDMA InfiniBand, then you are quite capable of having something about 20 gigabyte per second network throughput. Of course, if you're having 100 gigabit Ethernet, then you're up to 10 gigabyte per second. So that's the boundaries. And usually RDMA is faster than Ethernet in the setup or in the speed. We always prefer to have an RDMA connection between metadata storage and clients. So this is the fastest way for communication of all of the BeeGFS services with each other.
Yes, yeah. All in all, it's actually close to wire speed. And due to the user space architectural concept is actually the hardware components, the interconnect and the underlying file system, the limiting factor on BeeGFS. So actually we can configure everything, depends on the budgets, the performance requirements and the capacity requirements and the number of clients. And yeah, so it's really close to the wire speed and delivering full bandwidth to the clients, because we are getting on IO node level the full bandwidth up to the clients and deliver this maximum bandwidth. All right, 400 gig switches.
Oh, that's very good numbers, Andre.
Yeah, that's very good.
So, and there's one in Q&A.
Yeah.
in regards to high availability. So high availability in BeeGFS is not as much integrated as in Spectrum Scale. So we heavily rely on third-party tools like Pacemaker and ChorusSync to set up high availability for BeeGFS. And we're having several solutions regarding if you're having a shared nothing approach or a shared storage approach. We prefer to have the storage on shared storage. You can have the metadata if you want to on a DRBD with a shared nothing approach or on shared storage as well. Management server, which of course there's only one management server in the BeeGFS cluster, which most people clearly see as a single point of failure. So, but because the management server has not much to do, it's easily replicated with the help of DRBD. So you can make the management server high available as well if you want to. But as I said, it's not included into BeeGFS. Those are all third-party tools which must be purchased additionally. So if you're using, for instance, Red Hat Enterprise Linux and not CentOS, so you must purchase the high availability package from Red Hat as well. And the same applies for SUSE. If you're using SUSE Linux Enterprise Server, you must purchase the high availability package as well in addition. And if you're using the open packages like CentOS or OpenSUSE Leap, then of course everything is included, but that's not officially supported by ThinkParQ.
Right. We have 2 more questions coming in on the Q&A. So there's also how is NFS and CIFS access provided? Is it through some special protocol nodes? And do we have high availability for NFS and CIFS nodes? No, we are providing here re-exports for NFS and CIFS. That's the access from BeeGFS to the Linux world and the SMB world. And yeah, these nodes need to be set high available somehow, but it's not covered from BeeGFS. Am I correct?
Yeah, partly. If you want to have a high available CIFS support, then we usually advise or propose to use Samba CDDB, both the clustered version of Samba, because that's capable of running on all of the BeeGFS clients that you want to use for CIFS export. And so you can create some sort of load balancing. NFS is difficult. Well, usually you just have one IP address. And so, of course, you can try and set up a load balancer in upfront for your NFS, but that makes it a little more complicated for the NFS to set up. So with Samba CDDB, it's easier to have a CIFS export high available than having an NFS export high available and load balanced.
I'll make one comment about that, especially because a special protocol node makes me think this is from a GPFS standpoint, and that there was always extra licensing costs and stuff involved in setting up protocol nodes, and that is one really nice thing about BeeGFS is that that's not required. It's any client could then export via NFS or CIFS without an additional cost.
Right. Final question from Becky. Does BeeGFS have any features that help to facilitate HIPAA or CUI type data? That's a good one. I don't know.
So HIPAA is the medical data in the US standard. So I would say that there's probably nothing really built into the file system separate that would help with that. But it does definitely support permissions and ACLs, correct? So that could help in some regard, but there's no built-in facility to really support anything fast at.
Right. Right. Thank you.
Yes.
Thank you, Becky, for this good question. That's increasing my learning curve. Right. Good.
Yes, we want to thank everybody for joining us today for this webinar and thank everybody for their questions. At the end of this webinar, we're going to be sending out an email to everyone with a survey asking you if there were any questions that we didn't answer. You can ask them there. Also inviting you to let us know if there are any topics you want to hear about in the future. We'd be happy to think about that when we plan future events. We want to thank you for joining us. I want to thank all the presenters for sharing their expertise today, and we hope you have a great day.
Yeah. Have a great
Thanks,
day.
everyone.
Stay
Have a great
safe.
day. Bye
Thank
bye.
you for your time. Bye-bye.